Hello YouTube and welcome to What the Math. In today's video we're going to be continuing chapter 15 of IB Math Studies and focus on the sine rule, yet another rule related to triangles that are not right triangles. So let me show you what this rule entails and why it's important. So what is the nutshell of the sine rule? It actually is kind of written right here, but let me just explain this to you as well. So essentially it refers to the fact that a sine of an angle, let's just look at this angle here, a sine of angle A divided by the length of the side A. So if you take the sine of A and you divide this by just the length of A, will actually be exactly the same as the sine of angle C divided by the side C. And once again, it will also be the same as the sine of angle B divided by the length of side B. And this is just a rule that applies to any kind of a triangle. So if you take any triangle, and let's just say, well, it doesn't really matter what triangle you take, let's just say it's a right triangle or not a right triangle, a sine of angle and the opposite side, so sine of angle divided by the opposite side will always be equal. So this is a constant ratio in every triangle. And you can actually test this just to see if this is right. Let's actually just take a look at the most famous triangle. We're going to take a look at the, this is going to be a right triangle, but it doesn't have to be a right triangle. But this is the triangle that we always, I think we're all familiar with, the so-called Egyptian triangle, or the Pythagorean triplet triangle, where you have 3, 4, and 5 as sides. So this here will be 90 degrees, right? And the sine of 90, if you know, or you should know, is of course 1. In other words, if I were to write this here, sine of the right angle, I don't really have a name for it, but the sine of 90 degrees divided by, what is this? This is 5, right? Is going to create this constant ratio. So what is this ratio? Well, we know that sine of 90 is 1, and this is 5, so it's 1/5. So this ratio for all of the other angles and sides should be 1/5. And let's actually test this. Let's see if this is right. So technically speaking, or I guess according to this rule, let's name these angles now. So we're going to name this angle A, and we're going to name this other angle B. So this means that if this is all right, the sine of A divided by 4 should also equal to the sine of B divided by 3. And of course, this all has to equal to sine of 90 divided by 5, or 1/5. So let's see if this is right. Let's actually find the sine of these two angles. So we don't actually know these angles, and we can use trigonometry to find them. So if you remember correctly, this angle A is actually a cosine, or cosine of A here is going to be 3 divided by 5. So let's find the inverse cosine of this angle. In other words, let's find the inverse cosine of 3 over 5, and this will give us angle A. So inverse cosine of 3 over 5 is approximately 53.1 degrees. And so right now we can actually right away find the sine of this. So sine of our answer is going to be 0.8. So this right here is 0.8. So I can rewrite this as 0.8 divided by 4. And what is 0.8 divided by 4? So let's do answer divided by 4. And look at that, it's 0.2. And if you know your decimals and fractions, this is once again 1 over 5. And you can also test this for the other angle, and it will give you exactly the same ratio. So here, the ratios of all of these angles will be the same. Now, if you have this ratio, we can now actually find this angle, right? So let's actually just find this angle B using this particular rule, and also using what we just found as the ratio. So if your ratio is 1 over 5, we know that the ratio is 1 over 5. That means that the sine of angle B divided by 3, which is the side here, should give us this, right? So this ratio will equal to this ratio. So can we find sine B? Of course we can. Multiply both sides by 3, and this will give you 3/5 equals to sine b. In other words, we're looking for the inverse sine of 3 over 5. So inverse sine of 3 divided by 5 here is going to equal to 36.9 degrees. So this will give us b as 36.9 degrees. Now, does this make sense? Well, we found that the other angle was the angle B was 53.1. So if you add them together, it should give you 90. 53.1 plus 36.9 is exactly 90 degrees. So it does make sense. So this is actually what the angle is for, the other angle is for this so-called Egyptian triangle or Pythagoras triplet triangle. Anyway, so this is the essence of the sine rule, and it's very, very useful because you can basically now find either sides or angles if some of the things are missing and the triangle is not a right triangle. So let's actually see one of the examples from the book. And specifically, I'm talking about example 18 from the book, and this is basically the super simple problem that asks you to test or to use the sine rule using this triangle. So find the length of BC, so find this using the sine rule, and find it in 3 significant figures if you have these two angles here and you have this side here. So this is one of the ways of using this particular rule, is if you have two angles that are right here or anywhere really, right, two angles in a triangle, and then you have one side. So you can now use the sine rule to find all other sides, specifically side BC. So according to the sine rule, the sine of the opposite to the side, so the sine of 47 degrees, divided by BC, divided by the side, should equal to sine of 29 degrees divided by 5.6. This is the sine rule. So sine of the angle divided by the opposite side equals to, they're basically equal to each other. So this ratio is constant. So here we don't really know what BC is, so we're looking for BC. So let's isolate it. Let's actually rearrange this formula so BC is isolated. So here, if you rearrange this, sine 47 divided by sine 29 times 5.6 will give you BC. And let's use the calculator to quickly find this. So sine 47 divided by sine 29 and multiplied by 5.6 will give us 8.45. 8.45 is the length of side BC. So this will be 8.45 centimeters, and this is basically the answer for this particular example. Now, so when do you use sine rule, and when do you use cosine rule and everything else for that matter? Let's actually take a look at some of the problems where you would be using sine rule as opposed to other rules. So example number 1, or I guess idea number 1 is, if you have a right triangle, do you use sine rule or cosine rule? Well, no, you don't. You don't have to use sine or cosine rule. You just have to use Pythagoras theorem, which of course here would be b squared plus c squared equals to a squared. And of course you can or should use sine, cosine, and tangent ratio. So in other words, for example, for let's just say this angle here, this is angle B. So here, cosine of B would of course equal to C divided by A. So you would just use normal sines, cosines, and tangents, and Pythagoras theorem if you have a right triangle, or if you have a triangle, like for example isosceles triangle, that can then be turned into a right triangle. So if you have something like this, where you can make your triangle into a right triangle, just use Pythagoras theorem and normal sines, cosines, and tangents. Now, number 2 is when you have a triangle that is not a right triangle. So anything that is not isosceles, anything that cannot be turned into a right triangle. And when that occurs, you do have to use sine or cosine rule, or sometimes even both. So here's kind of a guideline from the book that helps you understand it. So use cosine rule when you have all 3 sides. So for example, let's name them. If you have A, B, and C, if you have all 3 sides and nothing else is given to you, then you would have to use cosine rule, which I'll remind you what this is. Cosine rule for, let's just say this is side A, so it would be angle A. So here, if you want to find this side, it would be a squared equals to b squared plus c squared. Starts the same as Pythagoras theorem, but then minus 2bc multiplied by cosine of the angle, which is why it's called cosine rule. This is the cosine rule. So if you have three sides, or if you have two sides and an included angle. In other words, if you have a situation where it kind of looks like this, you have two sides, A and B, and you have the angle between them. It should probably be angle C. If you have angle C between them, and then this would be the length C, and you're basically trying to find the C. So then this is when you would use cosine rule. Sine rule, however, is used when you have only one side and two angles. So let's just say you have something that looks like this. You have one side A, and then you have two angles given, and it's not a right triangle. Or it can be really any angles. The angles can be anywhere. So you just only have one side and two angles. Then this is when you would use the sine rule. You would use the fact that this is B and this is C, and this angle right here is A, and you know that sine of A divided by A creates a constant ratio. It will equal to sine of B divided by B and sine of C divided by C. So this ratio will be constant, so you can actually find any side using this. As long as you have one side and two angles, or if you have two sides and not included angle. This is actually the important part, when you have two sides and an angle that is not included. So when you have a situation that kind of looks like this, you have a side and a side, so side and a side, and then either angle here or angle here, and basically the angle that is not between the two sides. When you have one of these angles, then that's when you use the sine rule, not the cosine rule. So this is kind of the important difference between them. But overall, you'll usually find questions where you have to use either one of them or sometimes even both. And sometimes it's actually easier to start with the cosine rule and then switch to the sine rule to finish the problem, because it will save you some time. So do try to understand both of them, as both of them are quite important. Now let's take a look at a slightly more challenging problem where you most likely have to use the sine rule, or possibly cosine rule, or possibly even both. And this is actually a problem that has been used quite a lot. It's a very, very common problem. When you basically have some kind of a mountain or something that's tall, and then someone is on a boat or on the ground and looking up, and then what you're told is that, well, when this person is over here, when this person is at point A and they're looking up to T, the angle of elevation is 29.7 degrees. When they're right here, the angle of elevation is 41.2 degrees. And the other thing you know is that the distance between A and B, so the distance right here, is 1,473 meters. 1,473 meters. And that's all you know. And then you basically have to find either the height or maybe like the total distance. In this case, I think we're looking for the, is it the height? Yes, we're looking for this height, which is going to be our x. So find the height of the mountain. And so how do we do this? So what do we do? Well, obviously we have two right triangles here. So in some sense, you don't even have to use cosine or sine rule if you don't want to. So how do we solve this? Well, there's really two major ways. One is to use a quadratic equation by turning this right here into another variable and basically solving this using normal sines, cosines, and tangents and another variable that you're looking for. Now that is the longer way. It will probably take you about 5 to 10 minutes to solve this. A much easier way is to use the either sine or cosine rule. Specifically here, we're going to be using sine rule because we're going to assume that we don't really have a right triangle here, and what we're going to look at is this triangle right here. I'm going to actually circle it for you so you see it, and by circle I mean I'm going to change the color of it. This is the triangle we're going to be looking at. This triangle right here is obtuse, and we can find all of its angles. How? Well, look at that. This angle is 41 degrees. These two angles together form 180 degrees, which means that we can find this obtuse angle. What is it? Well, it's 180 minus 41.2, which is, I think it's 138.8 degrees. So this angle is 138.8, which now means we can find the remainder angle right here, and so this will be this angle right here. I'm going to draw it in yellow. So this angle is actually 11.5 degrees, because we know that sum of all angles on a triangle is 180 degrees. So okay, so we have all three angles on this obtuse triangle. Can we actually use this to solve anything now? Oh, of course we can. So what we can do now is we can use the sine rule to essentially find the ratio of all of the sides and angles in this triangle. Specifically, what we can do is we're going to use, let's name these angles. Let's make this is going to be side A, side B, and side C. So sine of A, which in our case is 11.5 degrees, divided by the length right here, the side A, equals to sine B divided by length B, and of course sine C divided by C. And what we would do with this now, well, we can find side C, which is actually hypotenuse in this particular triangle, in triangle TBN. So this will allow us to find side C. So let's actually look at side C using slightly different colors. So sine of 29.7 divided by the side C equals to sine of 11.5 divided by 1473. Now, if you rearrange this and solve for C, what you'll get is that C equals to approximately 3,660 meters. So this length right here is 3,660, and we found this using the sine rule. Now, okay, we have this now. Can we find x? Of course we can. We have this angle, and we know that the sine, now we're looking at this different triangle, we're looking at this right triangle here. Sine of 41.2 divided by actual x that we're looking for equals to what? Equals to, this is 90 degrees, sine of 1, or sine of 90, which is actually 1, divided by the side we just found, divided by 3660. So let's solve this. So basically, we know this is 1. We can actually just replace this with 1. In other words, it equals to 1 divided by 3660. And what you're doing now is solving for x. And x equals to sine of 41.2 multiplied by 3660. So that will give you your answer, which will be 2410 meters. This is the final answer. So this is actually a slightly quicker way of solving these types of problems using nothing but sine rules. The alternative, of course, would be to use a quadratic equation, but here, if you realize that you can actually find this side in this triangle using sine rule, and then of course you can find this side using sine rule as well, because these angles that are given to you have the opposite side, which you can find using sine rules. Anyway, so this is how you would use the sine rule to solve the slightly more complicated problem where you have you're given some angles, there's more than one triangle, and where you can actually find the opposite side to an angle, realizing that you can find all of the angles in the triangle. So here what we had is we essentially had one side and we had two angles, right? We had this side here, and then we had this angle, we had this angle, and we also had this angle as well. So once you have two angles and one side, you can find all of the other sides in a triangle using the sine rule, which is right here. So basically, this is the essence of the more advanced trigonometry that you'll be using on your test to solve various triangular problems. And this really concludes the trigonometry unit in chapter 15. Hopefully this is all clear and you are now the master of trigonometry. Thank you for watching, please subscribe, and good luck to you. Bye bye.